Awesome. Thank you. Just make sure this works. Great. Perfect. OK. So today, I'm going to be talking about decentralized infrastructure in a multi-chain world. I know this is an Ethereum conference, but I'm kind of here to convince you that the future is multi-chain. So let's kind of take a step back in time. 1994, Nick Szabo publishes a paper where he defines what this idea of a smart contract is. And what he basically says is that smart contracts are computerized transaction protocols that execute the terms of a contract, right? Just completely visionary. In that same paper, he also creates this idea of a token, which it's a little more abstract in the way that he describes it, but I think you'll find it sounds very familiar, right? And he says that these new securities are formed by combining securities and derivatives in a wide variety of ways. Very complex term structures for payments, can now be built into standardized contracts and traded with low transaction costs, right? So this was 1994. I mean, before some of you were even born by the looks of the audience here. So what can we say then? Well, in 2013 then, when Nick Szabo says something, we should probably listen, right? And so here in 2013, right, you have Nick Szabo basically saying that, right, there's going to be this polycentric blockchain ecosystem, right, that the future is going to be multi-chain, right, that we're going to have a diverse array of functionality, security characteristics, right, that would be difficult to achieve all on one, single almighty monochain, right, and that a polycentric system, right, is more resilient, right, to pressure, right, and then it's also more innovative, right, because competitive pressures, right, will cause these chains to evolve. Okay, so Nick Szabo was right. In the decade that followed, right, we have this hugely diverse array of blockchains. Don't kill me if you don't see, one of your favorite chains. They're not in any particular order. I just needed to get the logos on the page and kind of have them line up, right? So we're not maxis of anything here, right? But now what, right? Are we living in this kind of like multi-chain utopia? Like, have we solved all of the problems? Well, not quite, right? We kind of have new challenges that we need to address, right? So with a show of hands here, who has used more than one blockchain? Amazing. So let me pick on someone. You, sir. Which? Yeah. You looking back. Which chains have you used? Okay. So which one was first? The very first one for me was Bitcoin. Bitcoin. Okay. So when you switched from Bitcoin to, I'm guessing maybe Ethereum was the second one. Were there any challenges that you encountered? Anything new that you needed to learn? Was it difficult to use it the first time? Mm-hmm. Exactly. Do we have any developers in the room? Okay, great. So any developers that have worked on multiple blockchains? Okay, you sir, which chain did you start with? Ethereum. Ethereum? Yeah, Solidity. And then what came after? Kunkel, Substrate. Okay. You dropped it. Okay, no, that's interesting. You dropped it very fast. Why? Why? What was different about what you could do on Ethereum, and then like how was the developer experience different?
Well, the entry level was way more bigger. So because you have to learn Rust, which is very different from Solidity, and Substrate as a framework. I think that was 2019. So it was like very early ages of Polkadot and Substrate, and it was not ready yet for building production ready stuff. I just realized that the entry level is way higher, and I would get more money by just writing Solidity concepts.
Yep, 100%. Amazing. Right, so I hope you're starting to notice some like common themes here, right? That there are certain characteristics of different chains, right, that present challenges both to users and to developers, right? And so, there's certain chains, right, have taken certain strategic approaches, right? We sometimes classify chains as being like EVM or non-EVM, right? And as a developer, right, if you have worked on an EVM chain, right, it's incredibly appealing to be able to jump to a new chain, right, and not have to redevelop your smart contracts, right, to be able to recycle a lot of the developer tooling, right? So maybe on a newer chain that's not EVM, you don't have some of the advanced like stack traces and stuff, right? It's great to be able to use, right, simulation tools like Tenderly or auditing tools, right? So there's incredible synergies when we have this standardization of infrastructure, right, between these chains. So, and in the few instances where we have this synergy, this kind of standardization of infrastructure, it's proven really useful. Right? Like as a user, right, if a chain doesn't use MetaMask, I can tell you like most people just will not use that chain, right? It's just too different from what they know, right? The ability to recycle your keys and not need to have different keys for different chains, right? This is all very, very useful, and we need to do more of this kind of stuff. So, in light of that, these are kind of like the three takeaways of what I think we need to aim for in decentralized infrastructure. We need to be compatible, we need to be interoperable, and we need to be verifiable, right? So let's kind of walk through each of these, right? So we want infrastructure that's going to be compatible across all chains, right? We don't want to have to reinvent the wheel. It's a waste of time and resources, right? And it throttles, right, the most important thing, which is, right, that we just want to get on with our lives and like make the dapps and innovate, right? 2, interoperability, right? Blockchains need to be able to talk to each other. They need to be able to talk to the outside world, right? That's the only way that you're going to take this like fragmented islands of like pockets of functionality and utility and liquidity, right, and merge them together, right, as this interoperable kind of property, right? That's really useful. And third, right, we need the infrastructure to kind of have provable integrity, right? We need the transparency, right, for everyone to be able to verify this integrity, right? Not just some fancy computer or like developer, right? You as a user should be able to have like, to be able to see and understand these integrity guarantees. So, breaking down kind of compatibility a little bit, right? There's reasons why, we talked about the EVM, right? There's reasons why many chains adopt the EVM, right? It's not that the EVM is the greatest virtual machine in the world. It's really not. Actually, like if I'm being honest, it's quite poor. But it's really useful, right, for bootstrapping your chain, right? You get all the developer tooling, you get users don't need to generate new keys, right? You get things like MetaMask, right? So the interfaces for users to use applications, right? You get all of this stuff for free, right? And you can quickly bootstrap your ecosystem, right? Developers can just port their existing contracts onto your chain, right? There's a lower barrier to entry, right? You talked about this, right? The lower barrier to entry to being a developer and moving to a new EVM chain. It's easier for the developers of that chain to find talent, right? Because there's already a skilled workforce, right? So these are very natural, like organic forces that push us in this direction, and they're good, right? They're not bad. Going into interoperability a little bit more, right? What makes DeFi so powerful, right, is its composability, right? Has anyone here used 1inch before? Yeah? Do you remember the first time you used 1inch? Like that wow factor of like, I don't have to go check for like the best price anywhere, right? I just use this application and it just magic happens, right? That like feeling, right, that magic happens, right? That's composability, right? It's the ability, right, to stack all of these primitives on top of each other. And, you know, right, even something like Yearn, right? Instead of trying to cycle your funds between Compound and Aave and any of these other yield-generating, right, protocols, right? You know, Yearn would just rotate you to wherever the best rate was, right? These are really powerful network effects that are only possible because of composability. And so now when we talk about multiple chains, we need composability across these chains. And that's really, and that's kind of where interoperability comes into play, right? Interoperability, the ability for chains to communicate with each other, is what's going to enable multi-chain composability. Oh, sorry. I guess I forgot to switch the slide here. But anyways, and the last one, right, is verifiable, right? We need this infrastructure to be credibly neutral, right? And have the transparency, right, for people to be able to verify the integrity of this system, right? There's too many infrastructure services that right now both users and applications rely on that are, you know, complete black boxes, or they're totally centralized, right? And we don't have strong integrity guarantees there, right? You know, others claim to behave in an unbiased manner, but we have no way of verifying that, right? You know, just to get into a few like recent examples, right? Relatively recently, right? Tornado Cash was sanctioned, and you may or may not have very strong feelings about, you know, your ability to use Tornado Cash, but it should be your choice. And the way that we've designed our applications to be dependent on these more centralized, right, infrastructures has disenfranchised us of that choice, right? So to give you an example, right, Flashbots. When Tornado Cash was added to the sanctions list, Flashbots would only generate OFAC compliant bots, right? And this is really dangerous, right? Because you know, deciding, you know, what goes in or does not go into a block and like censoring on the block level, right? This is really, really, really low level, right? Censorship, right? I'm not trying to argue, right, that we shouldn't, as an industry, right, we shouldn't comply with our compliance obligations, right, or that we should. What I'm just saying is that it shouldn't be that far down the stack, right? It should be something that happens on the application layer, right, where each application, according to its own circumstances, right, or even the users, according to their own circumstances, right, choose, and not have it be, right, way down the stack. And we risk, the more we use, right, some of these centralized services, for example, Infura also, right, banned any transactions involving Tornado Cash. They even do it today, right? So if you are using, you know, MetaMask, right, you're implicitly using Infura, you will not be able to do a Tornado Cash transaction today, right? Because it's being censored on the infrastructure layer, right? So it's very important, right, that we have infrastructure, right, that is credibly neutral and that we can verify, right, its neutrality. Okay, so with that, I want to get to you that all of these challenges, right, of having infrastructure that is, compatible, interoperable, and verifiable is why I created Chronicle. So Chronicle is building decentralized infrastructure, right, that is compatible and interoperable among all blockchains, right, and we want to do it in this transparent and verifiable manner. And so you might be thinking that, you've never heard of Chronicle, we're probably some new protocol. Well, actually, we're one of the oldest and most battle-tested protocols in pretty much like blockchain history. So we spun out of MakerDAO, and I was part of the team that launched the first, I would say one of the first. I think Oracle beat us to the punch, but one of the first Oracle protocols in all of Ethereum, and really just one of the first protocols, period. Right, so we launched this in conjunction with the launch of ProtoSci, which was the precursor to single collateral DAI. And since then, right, we've been securing all of the assets and loans that were extended from Maker, which currently today is $10 billion. And in previous years, right, during the bull run, this number was even substantially higher. So that actually puts us, in terms of total value secured, as the second largest Oracle provider, right after Chainlink. And this is sourced from DeFi Llama. You can check it yourself. Okay, so I want to talk a little bit about the architecture that we've made, and I hope to be able to describe to you, right, why we're compatible, why we're interoperable, right, and why we're verifiable. Why you should be able to, with your application, right, or as a user using applications that use Chronicle, why you should be able to trust those applications and those services. So we start with this concept of feeds. Right, and feeds, you can kind of think of it as like as validators, right, or signers of a multisig, right. The point is that you want to have this distributed consensus being made, and you want these feed clients to be run, right, in a distributed fashion, right. You don't want any point of centralization, right, or coordination centralization either. And what these feeds do, right, is that they're constantly just querying data, right, from, let's say, if you have a price oracle, right, querying data from exchanges, querying data from on-chain, right, if it's an oracle for powering a bridge, right, you may need to know what's happening on blockchain A and report that, right, to blockchain B. But again, right, the way that you query data, right, you need to have redundancy and resiliency within this process as well. So we don't actually just have one tool for querying data. We actually have multiple implementations. So in this chart, right, it's described as Gopher and Setzer. So Gopher and Setzer are completely independent implementations, right, that implement the same kind of data standard. And the idea is, right, that if one tool were to fail, right, we still have fallback on a different tool, right? And that's very important. Building up, right, this resiliency, so one bug, one failure, right, just doesn't take down the entire network. So what do these feeds do? Well, after they get the data, right, they do some data processing according to a data model, and then they sign it. And once they sign it, they broadcast this kind of this message, right, to what we call a transport layer. And transport layers are peer-to-peer networks, right? So there's no centralized server or anything involved, right? There's no bootstrapping nodes or something, right, where if someone's not running one of these, right, that no one can connect to the network. They're completely open networks. So you could try to connect to any of these networks right now. So we have libp2p, we have secure scuttlebutt, and actually we just last week implemented a third one, You may have heard of it. It's called Tor. So between these three different networks, all of the messages, all of these signed messages are broadcast to all three of these networks, right? And in the future, right, we could even add additional networks, right? And the idea is, even if there is a 0 day in one of these networks, right? Even if there is a DOS kind of attack, right? Even if there's a way to compromise one or more of these networks, that the architecture is kind of, that the data is kind of like water, right? It will just flow through the path of least resistance, right? And the data will get through in some way, right? So this idea of resiliency behind the infrastructure is incredibly important to us. And then on the other end of this network, you have what's called relays. And relays are essentially just homologating all of these batches of messages from these independent feeds and compressing them into a single transaction, which then gets pushed on chain to a smart contract. Relays are permissionless. Anyone can run a relay. You can run a relay right now. Even without running a relay, a user could just go to our website, push the button, say, update, I want to update the price, and the price will be updated. You'll sign the transaction and pay the gas. But it's important, right, that this, even without incentives, that this is like an open, kind of like permissionless role. And so one of the things that I want you to notice about this architecture is most of it is off-chain. It's not on-chain, right? It's not specific to one particular blockchain. And this is what gives us that compatibility feature, right? In that only the last mile, right, has anything to do with the blockchain, right? And so it's really, really simple to deploy this infrastructure across multiple blockchains, because the only thing you need to change is, well, which RPC is the relay you're pointing at? On the topic of interoperability, right? Is this architecture interoperable? Well, yes, because the data source can be anything. It can be, yes, it can be an exchange like Binance or Coinbase, but the data source can also be another blockchain, right? And so if you're gathering data from blockchain A and relaying that data to blockchain B, right? Attesting to blockchain B that, hey, something happened on blockchain A, right? That is how you get interoperability, right? That is how something can happen on blockchain B based off what happened on blockchain A, right? And the last is verifiability. Oh, sorry. We'll talk for a second first about the feeds. You might be wondering, well, who the hell is running these feeds? Why should I be trusting these people? So the feeds right now are run by the projects that you see behind you. Most of them have been running their feeds since, I want to say over 24 months now. Most of them right around the time of the launch of multi-collateral DAI, which was in December of 2019. So we have some great partners. We love working with them, and we're constantly looking to add more. Right? And essentially, right, what we look for is we want someone that has, right, high credibility and a high reputation in our ecosystem. Because essentially these feeds, right, are the entities that are reaching consensus, right? And they're effectively staking their reputation, right? So if, for example, let's say Maker, right, were to try to participate in some kind of Oracle attack, I mean, it would be, suicide, right, for Maker's reputation. And Maker might lose a lot of their users, because why would anyone want to ever, use or interact or benefit a protocol, right, that is a bad actor, right? And so essentially the trust model here is that, like, maybe you don't trust like individually like one of these protocols on here, but the consensus of all of the protocols in our industry, right, the community consensus, that's harder to argue with, especially when you use some of these applications every day and already implicitly trust them. Okay, so this is kind of this idea of verifiability, in that we don't just want cryptographic liability, but we also want verifiability, right, to like the layman user, right? So very frequently you'll see like an oracle and just be like, here's the price, right? And you're just like, how did that price come about? Or maybe I understand theoretically how it came about, but like I cannot track the steps from like, here is where we got the data and here is how we transformed it, and that's how we achieve this number on chain. So kind of below the chart, right, we basically have a list of all of the feeds that were used during the consensus process, right, for reaching, right, the canonical price of the oracle. And then if you were to click on any one of these feeds, right, you'd be able to see the exact data sources of how each individual feed arrived at that price, right? So here you can see, right, that we pulled the ETH Tether pair from Binance US, right? We pulled the ETH USD pair from Bitstamp, right? We used an on-chain source. I believe that one is Uniswap v3, right? We used Coinbase. Right, and the feed took all of that data, right, and decided that after crunching it through the model, the closest price was this one, right? That's what it ended up reporting. All of the feeds individually do this, right? And now you can use different types of consensus models, right? So in this case, we're using a median, right? But there's no reason why you can't use a TWAP, a VWAP, right? You can transform the data in any way you want. It's just based off the definition of the data model that you plug in. And these data models are also on-chain. So there's an on-chain register, right, where these data models are defined. So when we say, well, how do you decide? How does a feed decide what the price of ETH/USD is? Well, you can go check in the on-chain register. Here is the data model, and the feeds are querying this on-chain contract to get the data model, right? So it's not like some pre-programmed thing, right, where we can just slip in some hard code, right, where the developers overwrite the rules of what ETH/USD is, right? We cannot do that. So I mentioned earlier, right, that this architecture is compatible with any chain. EVM is super easy, right? Because it's really just, even the smart contract is just deploying the same contract on every chain. But even non-EVM, right, is not difficult, right? You have things like Solana, you have things like Cosmos, and the only thing that you change, right, is you change the implementation of the smart contract, but everything else stays exactly the same. So we're publicly live on Arbitrum, Optimism, and Ethereum, but we have 6 other blockchains that we're kind of doing in secret right now, and that will be announced in the next couple of months. We're going to have a particular focus on the layer 2s, but some of the more popular layer 1s will be in there as well. So, you know, if you were interested in what I talked about here today and you want to find out more or you want to stay updated, you can follow us on Twitter or join our Discord by there's an easy link by going to our website. If you would like to use Chronicle in your applications, you know, you can reach out to me on Twitter or reach out to me on our Discord, and we'll be happy to get something set up with you. And even if you're interested in working for Chronicle or working on Chronicle, we're always hiring. We don't care where you are in the world, right? You know, your salary is not going to be regionalized or any of that crap, right? We just want the best people, and we have like a remote distributed team that's basically across, I think, 14 different countries right now. So come talk to me, or even if you see me here, come talk to me, come find me. Let's talk. Thank you.
All right. Thank you very much, Nick. Do we have any questions?
Oh.
First question here.
Hey. Hello. So I have a question about the transport layer.
Sure.
So you had two independent kind of modules in the transport layer, which is lib P2P and secure scuttleboard, right?
Yep.
Why? And you also mentioned that you have the third one in
Yep.
a way. Why to have three independent like modules? Or are they independent? Firstly.
Yep, they're completely independent, right? And because one could get hacked, right?
Why not three of them can be hacked then? Like if one can be hacked, then why
they
not
could,
three?
but probabilistically, the more you add, the more less
Yeah.
likelihood, right, that all of them can be hacked at the same time, right? These are all open source protocols, so you would imagine, right, that over time, right, if they are compromised, right, that they will be fixed and they will become hardened protocols, right, and they will build up some Lindy. And I mean, you could even add a centralized server there if you wanted to. We actually had like an internal hackathon where someone actually created this cool concept of like, what if we just threw the data up on Twitter, right? And it's like, oh, well, Twitter's like, you know, terms of service doesn't let us, you know, just like put up JSON, into a tweet, right? You would get banned. And so what we ended up doing is we just said it's art, and we just encoded bitmaps with the data. And so you would just have feeds tweeting like all of these pretty like bitmaps, and we just said that they're like, you know, AI generated art or something, right? And so it's okay, but right now they're all right peer-to-peer distributed decentralized protocols, but you could still gain extra resiliency by using centralized services as well, as long as you're not reliant exclusively on centralized services.
And who currently run the nodes of these peer-to-peer services? Who operates the nodes of these products?
So the networks, right, are composed of the different participants on the network.
Yeah, true.
Right? So again, right, there's no bootstrap node that we run and then everyone connects to us. No, they're peer-to-peer, so everyone is just connecting with each other. So it's the feeds, right, that are part of the network. It's the relays that are part of the network. It's people that just want to monitor the activity of or performance, right, that are part of the network. They're open networks. Anyone can be part of them and join them.
Are there any incentives for people, for someone who wants to run the node in the transport layer? Are there incentives for it? Or
currently, no. We may add those incentives in the future, right, to make the network more resilient and robust, though. That's definitely something to think about.
Yeah. Thank
you.
you.
We have another question from the audience.
Cool. Thank you.
No questions? Great. Thank you very much, Nick.